Cool. So now it's time to recap. We're going to go over what we have here. We are no longer in that foo directory. We are in some of the bash course notes that I've written for myself. And we can see that there are 2 scripts that exist. Normally I like to write the scripts out for you, but we're going to look at the ones that exist and we're going to go through them together and try to understand what's happening. So let's look at the first one, commands and math. Pretty simple. I don't know why I have a comment saying edit these. That was probably a note to myself. I don't need to do that. That's fine. Ignore that. So we have name equals who am I, and we have number equals 2 plus 2. So what do you think the output of the script is going to be? There's no trickery going in here. I'm not trying to like lead you down a bad path, but look at this. Name is name and number is number. Should be pretty straightforward. It should say Dave and it should say number is 4, right? Hey, that's awesome. That's great. Let's look at the second example, okay? Things are going to get a little bit tougher here, but let's not get freaked out. Here's the next example. It is called arrays. So we have some functions here. We won't go into the functions yet, but we'll just look at the fact that we have a function called process indexed, we have a function called process associative, and we have a function called process commands. And this one has a comment saying, next to it. I'll explain why and why that could be dangerous. It is dangerous, but I'll explain why. Oh boy, we have a lot of stuff here, don't we? Cool. So we have command equals $1, and then we echo script called with arguments, and then we print the arguments the user gave us. Then we call shift. We haven't talked about shift yet. And then we say script shifted to arguments that. So we print the arguments out again. Okay, a little bit weird, but what we can do here is instead of going on and trying to understand the rest of the script, we could just call exit here. This way we could run the script and just see what those like 4 lines of code actually do without having to process any more of the script, which is what I like to do sometimes when I'm looking at scripts I haven't really seen before. I can kind of get an idea of what's going on if I start encountering things that are a little bit suspect, a little bit weird. All right, so let's go ahead and run that script now that we've put a manual exit in there. The script is what, 01 arrays, I think. Run this and we can see script called with arguments, blank, script shifted to arguments, blank. Okay, let's give it some arguments. Foo, bar, baz. Script called with arguments, foo bar baz, script shifted arguments, bar baz. So shift is a way of moving the array of arguments over by 1. So $1 was foo, and then we shift it, so now $1 is bar, $2 is baz, and foo has been lost. We've shifted off, we've moved away, we've moved the whole array over by 1. This is useful because we have command equals $1, and then we shift it, and by doing that, we can do a case statement over command, but the rest of the arguments here have had the command removed to them. So think about this as subcommands. That's kind of what's going on here. So let me go ahead. Let's get rid of this line, get rid of this line, and get rid of this exit. So now let's go down here. We have a case statement over command. So if we go back here, the command we gave it technically would be foo, and the arguments would be bar and baz, is a way of thinking about it. Let's pull back open the script. We can see that we look for the command to be the word indexed, the word associative, or the word commands. Otherwise, we print unknown command and we exit with an error code. So let's go ahead and just rerun this with foo, because that's an unknown command, and we get the error code 1, which is exactly what we expect, meaning it matched this leg of the case statement. Awesome. What if we give it the word indexed? What do we do? Well, we run process indexed and we give it all the rest of the arguments, not the name of the command, but just the rest of the arguments. So let's go ahead and look at process indexed to get an idea of what's going on. We take the arguments and we save it in as an array called arguments. Oh, I don't want to highlight every instance of that. That's a lot. So we have a new variable here called arguments, and that has every single argument that this function, this subcommand has been called with. And then we print the number of arguments. So if we gave it like foo bar baz, foo would be the command, bar baz would be the argument. So it would say 2. We can expect 2. Then we set the IFS, we've done this before, to a comma, and then we print out the arguments. Well, that seems pretty simple. Let's go ahead and just run the indexed example. Let's say indexed, foo, bar, baz. Let's run that. Found 3 arguments, foo, comma, bar, comma, baz. Hey, that's great. That's awesome. We could also say something like, hello, world, LOL, and give it commas ourselves as one big string because we've quoted it. It only found 1 argument. It looks like it joined up by commas, but we had done that ourselves manually. Of course, we could get rid of these. We could do this, and we could unquote it, and then we give it as 3 arguments, but we get the same exact output because the program did the job of joining them together. That's pretty neat. That seems pretty straightforward, right? What's the next one? Process associative. So let's go back down to the case statement. The case statement's very simple. If we give it the word associative, we run process associative with the arguments. If we give it the word commands, we run process commands with the arguments. Let's focus on associative right now. We take the arguments that the user gives us, we print the number that we found, and now we make an associative array called unique. So we make an associative array called unique, and can you guess what we're going to do? We're going to loop over every item. Notice that we declare item as local, so we don't bleed into the global scope. For item in arguments, we are going to loop over the arguments the user gave us. So in our case, if we gave foo bar baz, we're going to loop over foo, then bar, then baz. We're going to set that key equal to 1. We're just going to set the key equal to 1. And then at the end of this, we're going to print how many elements were in the associative array. Now, that's kind of interesting, right? So why is that interesting? Because if I were to run this, give it the words associative, foo bar baz, we can see that we had 3 total arguments and 3 unique arguments. What if we gave it foo, foo, foo? 3 total arguments, 1 unique argument. So basically, this is a way of sort of deduplicating our data and coming up with which one is unique by setting it as the key of this array, this hash map, this dictionary, whatever you want to call it, whatever helps you understand it. We just set it to 1, meaning, hey, we found this. We're setting this to anything. This 1 could literally be anything. We could just put like anything, LOL. And that's totally valid because it'll just be a string of anything, LOL, and it just works. So that's what's going on there. That is how that works. So cool. I think we understand process index, and I think we understand process associative. Let's move on to this last one, because this last one has a little comment that says, This last one's a little scary, but we'll talk about why. We read the arguments that this function got. So we get the arguments of the function, which will be foo bar baz in our example that we keep using. We print the number of total arguments. Okay, we've done this every time, not a big deal. Then we loop over each item. Notice that we don't specify this. We don't say in that. We just say for item. This is also valid. For loops in bash, if you don't give it anything to loop over, it will loop over the arguments. It will loop over the positional parameters, $1, $2, $3, if they are set. If they're not set, the loop won't do anything. So putting that, totally unnecessary. You don't need to do that. You can just say for item, totally valid, and it works. It's going to run the command, and then it's literally just going to put this here. Notice that there's no echo in front of it. There's no anything in front of it. This is going to get treated like a command. If I give it ls as an example, it'll just run ls. So let's go ahead and test that out. Let's call this commands, and I think it was foo bar baz, and we can see 3 total arguments. Running command foo command not found. Running command bar not found. Baz not found. Okay, it's great they weren't found, but what if I just did like, I don't know, ls uname who am I? Well, it ran ls, it ran uname, and it ran who am I. This is what I wanted to show you. Bash technically does have an eval statement. It can evaluate things, but you don't even need it. Bash will just run this happily. I can put the name of a command in a variable and then run it. Like, I could say var equals ls, and then I can run $var, and it just runs ls. So this might blow your mind. This might be a little scary. It's all just string manipulation at the end of the day. I just wanted you to know how easy it is to run commands like that you take from the user. And because of that, how scared you should be, and how, not scared, but how aware you should be of these things, how easy it is to accidentally run a command that a user gave you. You want to make darn sure that you are not mixing user input with code that is being executed. So what I mean is, this line down here that I have, you should never do this. This is just to illustrate a point. You should never have code like this. This is not how you want to do it. You do not want to mix user data with code that is being executed. That is a recipe for vulnerabilities if I've ever seen one. So be very mindful of this. But I wanted to show how powerful this is, how you can actually do stuff. And there's ways you can do this safely, of course. I'd probably do a case statement over a couple commands that I allow and then execute them in a way I like, blah, 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 blah. Yeah, you can do this in a way that's safe, but just be mindful of this. You just put a command in a variable and you can just execute it. Like, there's no rules.